Yes, we are live and in the new year, first meeting.
Happy New Year.
Happy New Year. Um, Venkat, you were proposing a plan for today? Do we
Yeah, I thought it would be interesting to spend some time reviewing, I don't know, some of the new developments that seem to be happening. Uh, the one that really caught my eye was the unitary dog robot. Like uh, they copied the spot, and now it's like it seems to have really advanced. But yeah, whatever seems to have caught everybody's eyes, and then maybe discuss uh, more broadly what we're doing with this project. Oh, and yeah, we can probably take a look at the web page and think about how we might want to rewrite it because now it's very easy to edit the web page.
Hmm?
Yeah, maybe we can start with the unitary. Has everybody seen the unitary dog?
Nope. I've been busy listening about NVIDIA saying that robotic AI is the next big thing.
Yeah, CES is going on right now apparently, and there is a lot of talk of robots. Though some people are cynical that it's a lot of like fake demos, as in people
Okay.
controlling humans controlling in the background. The Tesla demo, I think, was that kind of fake demo, right? The Tesla humanoid demo was somebody driving the robot from the background. But I think there's some genuinely interesting ones.
What about the Waymo demo? Because this morning I was waiting for in a room, okay, and there was a TV where they were reporting, so in Japanese, about the CES, and they were apparently saying that Waymo made a big announcement and big demos, and they had staff, so Japanese staff, trying their new taxi, maybe in California somewhere. Okay, they were testing the taxi.
Waymo has been running in San Francisco for more than a year now. More people now seem to be using it than Uber, and I think Austin is also emerging market. So
And I heard Lyft and Waymo were the same amount, and then Uber is still winning, but it's like
Yeah, I
40,
think Lyft and Uber
20.
have the same market share or something.
is this true even of San Francisco? Like, just maybe it's like just anecdotal. Somebody was saying, well, maybe it's the tech crowd I mostly know. They all seem to take only Waymo now. But yeah, it's and San Francisco is not an easy city to drive in. Like, I don't like driving there; it's a mess. So if they've actually done a good job there.
Didn't say I see just 2 days ago a guy was in a Waymo and it was going in circles around the airport and he couldn't get out. Was that a hack? Or is that a way to increase the ridership?
I've never actually ridden a Waymo, but I would imagine there's some sort of emergency stop feature.
Yeah.
Otherwise, it would
He
be
called
weird.
up and said, "What do I do?"
There have been weird things like that. They form weird gridlock jams in. I've seen several videos in Austin, especially. And then in the early morning, when they're leaving the parking lot, they have like weird jams in the parking lot. Hey, we get to see.
Yeah, I've seen the video of that. That one's pretty funny.
Yeah. Sorry, I've been invited while we were talking about robots because sorry, I have just to fix a toy while we're listening. I'm sorry. But so sorry. It seems to me the message this morning that I saw on TV, okay, is that apparently the Waymo technology is getting quite convincing because the big announcement for Japan is that Waymo is entering the Japanese market this year, and Japan would not let that happen if that was not, mature enough. I would say, because we have Uber here too, but they have a big. They have big difficulties because of the traditional taxi.
But that's true everywhere. I have a feeling nobody's really doing independent evaluations of or audits or anything. It's like nobody wants to be first, but now that San Francisco and Austin have basically been the first cases, the city officials everywhere are just pretending to do their own due diligence, but they're just saying, all right, we'll just like, I don't know, go through the motions and approve it. Oh, I shared the Unitary dog if you want to see that.
Thank you.
Yeah, so this,
Wow.
it was really doing some viral rounds in the last year. This is what impressed me.
Why are people calling it embodied AI? It's just robotics. Like, I don't know. It's like,
I think because these are not the traditional robotics methods. This is sophisticated enough that I'm thinking it's reinforcement learning, not maneuver automata or any of the old classical techniques. So there's this one, and I forgot where I found the other one, but they have a wheeled dog rover. Have you seen that one?
Yes,
That
the
was
one
very
yeah.
impressive.
Yeah. So
Yes,
that one,
plastic on it, right?
But this is wild that it's $1,600. Like that's
yeah, that's the equivalent from Boston Dynamics is 60,000. I think the Spot was 60,000 last I looked. But the base model here is 1,600. But I think the more realistically configured ones are around 6,000. That's the one they're demoing at CES right now.
Hmm.
But let me see if
And
I can find the Unitary.
is all of the AI processing happening on the dog?
I haven't really dug into it. This may be worth
That's
teardown
what
session.
embodied would mean.
China is
Yeah.
leading the way when it comes to dog robotics. This is the Unitary B2W, the latest variant from a Chinese technology company. And when this flagship quadruped robot is compared with the kind already seen under testing with the US military, China's is making Western designs look a little clunky.
This
The
is-
Chinese tech appears nimbler, sleeker, and incredibly agile. The wheeled leg design of the B2W gives it an edge on all-terrain activity, with combined perceptual and motor control maintaining acrobatic-like balance, allowing it to
How
stay
do you make the
surfaces,
wheel
rapid and
waterproof?
synergistic response
the motors?
multiple leg joints.
Like-
And it can even carry a person
I think
or
you
loads up to
do like
40
some
kilograms,
proof,
and it can
views of
reach
the
speeds of
accident.
30 miles per hour. AI is also driving the evolution of robots like this, and China is managing to churn out such designs more cheaply and faster than Western production chains. A robot dog race it could very well win. In a world where robotic dogs are already in active war zones like Ukraine, the rise of quadruped robotics and the possibilities of how they might be used is still evolving. It's certainly not the time to let sleeping dogs lie when it comes to staying ahead of the
And
game.
look, it's not
In
doing
war,
the
the
constant
robotic bark
motion of the legs to maintain stability. It's
needs to
able
come
like, just
with
snap
superior
and-
technological bite. Stuart Rumble, BFBS Forces News.
Thanks for watching. For more from BFBS Forces News,
I'm very impressed by the robotic side.
Yeah, and it does not
You know,
look
the
traditional to
movement.
me. The Boston Dynamics stuff, it looked. The reason I think it's not traditional is the Boston Dynamics. What's the humanoid and the dog? They looked like they had been trained by like basically motion capture. So that's the way they used to do it 20 years ago, where you motion capture human controller or something like that, and then you kind of learn the language of motion from some model reference like that. This is doing weird enough things that I think the training model is different. But yeah, I don't know. This is
So you're
that's why I
saying
think
it's
it's worth
not
a teardown.
mechanics? It's the same mechanics, but it's a different language of movements? If we
One learned through reinforcement learning is my suspicion, not like supervisory training or some kind of like grammar.
I
Yeah,
find
and-
this physical intelligence more like, at least seems more challenging than what Unitary is doing, because they are trying to do something in the unstructured environment.
What is this one?
It's I think Peter Abeel's startup, physical intelligence.
I mean, what is it? What is physical intelligence? Is it just
So physical intelligence is like the company name.
Okay,
It's
okay.
called Pi, and then they are trying to like first problem they are trying to solve is like laundry service robot. They are trying to
Oh,
do some sort of model that can do generalist
it says general
unstructured.
purpose foundation model. So this is also deep learning, not traditional robotics techniques.
But at the same time, Abil has always been working at the intersection of both. Okay, so for always, I mean, for many years has been working at the intersection of both. So maybe he sees that not only as deep learning, right?
Yeah, I heard of him first in a not deep learning context, but this stuff, the few phrases I caught looked like some version of deep learning.
Oh, it's not Peter Abil. I think it's Sergey Levy.
Oh,
Okay.
okay, that's different then.
Yeah.
Who is Sergey Levin? What is he famous for?
I think reinforcement learning in robotics.
Oh,
So
okay,
he has a specialized lab in UC Berkeley.
okay.
Not too far from Abil.
Yeah.
So, yeah, I mean, even just these 2 or 3 examples makes me think that we are way under indexed on AI. Like like for starters, we really should look at Yakasor again and ask, how would you do this different if it was like AI first design? Like so far we've been fairly traditional, but how would you do it if you started with Jetson is still the only kind of like hardware
Can you
solution, but
can you explain your question, please? What do you mean AI first design?
I don't know. That's just a phrase that occurs to me as a stub for the right question to think about.
As I haven't actually watched this, but apparently the Jensen keynote at, I guess it must have been CES, kind of put in place, they kind of explained their like omniverse strategy a little bit better than that it has been explained previously, about how all these different AI pieces fit together to work for robotics. And the way they broke it down was that, like, I think the tool chain is essentially, you get a small amount of data about the thing that you're going to do, and then you build a omniverse, essentially like physical environment where the actual training can take place. So you have a small amount of data, and then you use the omniverse to create a crap ton of synthetic data to generate an actual model that is then deployable. And so that uses like the big hardware. And then the actual model is then deployed on like their much smaller devices, like the
Jetson.
Jetson. Yeah.
This is what you are saying, right? What you described is basically this graph, it seems. So you have a small teleop demo and then you simulate it using this.
Can you make that picture a little larger? I can't see it. Oh, okay, there we go.
Thank you.
Yeah, and it's all still using the same components that we looked at.
This
About, like,
says
simulation
teleop,
stuff.
and there was a picture of a woman wearing VR glasses. So I'm imagining there's a little bit of teleoperation going on here.
Yeah, so
there
you
is
have to do something to generate kind of the first set of data about like what it is that you're trying to build.
There is another keyword I heard more this week since last week is Cosmos. It's next to Isaac, Cosmos here. Yes, and I've seen pretty impressive demos last week. Okay.
Is that the physics engine?
Yes, it's physics and generative engine. Yeah.
How would this change?
Please, sorry.
Sorry. No. Please.
Oh, no. It's just Cosmos. There is. It's a bit confusing. It's not very clear what does what. Okay, there is Cosmos something, Cosmos something. There are subparts to it as well. Sorry, that's all.
I wanted to ask, how would this change our design of the Yakasa itself? In other words, would we use different motors if we were planning on using this type of AI?
So my
would
initial
we require additional sensors?
I was initially thinking going exactly the opposite way, which is this is like weird and hard enough that maybe the focus should be on building a digital model and putting it into something like the Omniverse and doing things like, can we have, I don't know, looking at this like a skeleton teleoperation way, like somehow map the Yakusaur's actuators to human operations or remote control and control something in a simulation environment and see if we can actually go through this kind of process in at least a simple way. Because right now, like what Anuraj programmed for DevCon, for example, the frame has like, forward, backward, turn, which is like, the way you would have done it 10 years ago, 20 years ago, 50 years ago. That's how you would have done a robot,
Mhm.
right? Forward, backward, whatever. That jumping unitary robot seems to have like a much richer and much more, I don't know, basic way of like, I don't know, embodying its actuators. It might, I don't know what it does, but what happens, for example, if you learn at the level of voltage and current signals at the sampling limit? So, like what happens if you can like control the motor voltages and currents at the finest physical limit of resolution and don't attempt to define high level abstractions like right or left or forward, and then just give it like a high level goal, like just do whatever the hell you want with your voltages and currents, but the end state must be that this ball is knocked off the table. What would happen then? So that's it's a cartoon version of like the AI first framing of the problem. Like you won't, maybe it'll discover a completely different vocabulary of motion than left, right, forward.
And
Rather than a
maybe
control system implemented on the rover itself, you're deploying a model that has been trained somewhere.
Yeah.
Yeah.
maybe
With some
the opposite.
safeties, like you have like some hard stops where it says, all right, if you're coming to the edge of the table, just stop everything and hope things work. But within that, you do like basically, yeah, everything else you let it. I guess the similarity might be to how a baby learns, right? Like I'm not a parent, but several of you are, and from what I've seen of how babies learn their motor functions, it's like parents keep them somewhat safe, but otherwise they stumble around and like just figure things out. That's and there's weird things. Like I just saw this video of claiming to say that this is how you should teach babies to watch. So you guys tell me if it's accurate. So this dad had like a baby that had just was at the edge of like starting to learn to walk, and he held her up by her arms between his legs and then just ran very fast. So the baby had to like stumble and walk with him, but he was holding her up. But he did that a few times in random directions and then let her go, and she started walking. I don't know. This might be like a staged video, but this is like not an approach that would have occurred to me at all.
Most parents that I know don't want their kids to learn to walk faster. That's a state change in the parenting experience, and it's not one you want to rush into. I think I might suggest kind of doing the opposite of what you're saying, where like what we would be training is the safety boundaries, and like let the users push a Yakusaur around wherever they want, but it's the model that prevents any damage from happening. So you ignore, it's like, yeah, you can go forward, but the model won't allow you to run into a person or off the edge of a table or something like that. So you still have like an interaction of like, hey, I'm driving this thing around remotely. That's fun, but it's actually way safer than what we could ever encode in the control systems.
So what would be the signal you would train on? Would there be like bump sensors, and each time the bump sensor gets activated, it becomes a little more reluctant to go in that direction or something?
Yeah, or maybe not even, maybe, I don't know if in simulation you have to have bump sensors. You can literally have collisions until you've done failure.
Yeah, that would be it's not the opposite, but I think it's a complementary strategy, learning the safety constraints as opposed to learning the mobility affordances or something like that.
Yeah.
It's very interesting because it matches also architectures like subsumption.
Yeah.
What I mean by that is what Red proposes is that the lowest level, it's a safety basically, like what we have on a Roomba, where we have, IR sensors and bumpers, are safeguards. Okay. And on top of that, we have we have broader skills that can be shortcut by the lower level skills. Okay, it's precisely what subsumption is more or less basically. Okay, do you think we get back to that, right?
I would challenge that because subsumption starts with like a top-down definition of the horizontal levels that somebody came up with, like, what's the lowest layer, then the next layer, and then you kind of like somebody sat down and thought it through. Whereas I'm thinking actually I'm trying to see what's the asymptotic limit of this direction of technology, and I'm just seeing like say a mass of like tensors or whatever it is that are learning something, and maybe you set things up in such a way that in an emergent way, the first thing it learns is safety behaviors, because in an evolutionary sense, if it doesn't learn that, it'll die. But then the next level might be like, point-to-point navigation, and it learns that after it has figured out some basic safety. But if there is a subsumption type hierarchy, it would be sort of like emergent, and the layers would emerge naturally somehow at some sort of natural boundaries. Hey, Ellen.
Hey.
Good to see you.
Oh, hello.
Hi.
Hi.
Ellen has joined some of our other calls on like governance and distributed systems and occasions. And if I'm not mistaken, Ellen, your background is in controls and systems as well, right? Same as me?
Systems design engineering, so interdisciplinary engineering, but it included controls, yeah.
So we are speaking the same language.
Yes.
Yeah,
Also, way back in high school, I was part of a robotics competition of robots competing against other robots. So I did have some experience there a long time ago. But anyway, I have some interest in the topic.
Yeah, we are doing kind of like an annual bootstrapping discussion of like what's the latest news we're catching up on, the latest robots, and how should we think about them. So we just talked about the unitary dog robots. We talked about NVIDIA's announcements at CES. And right now we are talking about what an AI first robot architecture would look like, because what we've been doing so far is pretty traditional. Oh, and Ellen is in Canada, so we now have 6 countries represented in this.
Cool.
Ellen, we're live streamed and recorded.
Good to know. Okay.
So we're talking about subsumption.
I did a slightly different take. And my take was maybe we would have different controls and forward backwards. In other words, maybe the AI would generate a different set of atoms for us to use. I mean, I heard, I forget who it was, who was saying that, matches how humans see controllers of robot. There could be a different set of atoms, which makes more interesting, at least. Maybe not better than forward, backwards, and turn. It makes me think of these old remote-controlled cars, which had 2 options, forward and backwards with a turn.
Yes.
Okay, so there could be a different set, and if it's not too weird, it could be interesting. And what is for sure, it could be more appropriate for the Yakuza design in some sense that I'm not sure what it is yet.
But all of this will basically we have to think about the hardware to what it can run, right? So Raspberry Pi, like if you need some model running, then I don't know how fast it can run it. So then we are basically trying to get some GPU or NVIDIA Jetson Orin type of hardware if we want to go it that way.
That's why I was suggesting that this year might be a good year to focus on simulation. We'll continue doing our hardware builds, the Tumbler modification and the Galaxy. Those can go on as like our continued learning tracks. But a lower effort way to try the machine learning stuff would be in simulation, because then you can, you don't even need your own desktop GPU. You could run it on a cloud somewhere, right? Uh, and and there's other. I think, Mayor, you asked this question on one of my newsletters, and I responded
Yeah.
with that link to, I think, Janelle Shane's weird AI examples. That's all done in
Yeah.
simulation, like the robots learning weird behaviors. But you can also think of applying machine learning to the hardware design itself. Like you give it like some set of parts it can work with and some constraints, like you have two motors, two wheels, blah blah blah. How would you arrange it? Maybe it would come up with completely weird designs. So and
What
people
is what is the utility function for what you just said? In other words, I give it 3 wheels and 4 motors, and what is it supposed to optimize?
so the examples I'm familiar with, there is in San Francisco, there's a museum by the Autodesk. It's called the Autodesk Museum. Let's see if I can. And their main cost function is material minimization. So they throw AI at like various design challenges. Let me see if I can find a good example. They have like cars and stuff. Okay, I'm not finding any of the. Oh, there we go. Why is this not? Okay, so while I wait for that to maybe load. Yeah, so if you go to the Autodesk Museum, you'll find, for example, car design, race car, like sports car type design, that's generated by machine learning in AutoCAD, and it has like a very weird organic look. It looks like more like a tree that has grown in some weird way, and it's got like good sort of natural beauty, but it doesn't have like any of the obvious symmetries. For example, it has like weird
Right.
asymmetrical things, but it still looks fine. So that comes out of like material usage optimization. So that's one example. But you could do more constrained things. Like if you gave it like a constrained language like Lego and say, all right, this is the grammar for attaching wheels and motors to any part, just explore and find some way to attach 2 or 3 or 4 wheels to this set of Lego chassis options. I don't know.
That is, and also, of course, you have to develop the right movement for this unusual robot.
But this is where there are actually a full range of capabilities because as utility functions, so there is, for example, using minimum material, but also having, I saw that in the Autodesk 365 tutorials, because, you remember when Joshua was talking about OpenCAD and so on, I was looking at other things in parallel. And you can generate shapes that have physical properties, in terms of how solid they are, the kind of load they can get, whether they can be twisted or not, okay, depending on the materials and so on. And indeed, it looks like a corals, okay? They generate, so it looks like corals, but with some guarantees on their physical properties. And there is something else also we look at, I think last year, okay, was some American university, I don't remember which one, generating robots, in a TPU. If you remember, these were these purple, small, strange shapes, basically, but that had a very specific function. And so this is my point, is that another utility function is the environment itself. So, for example, if we go to some unusual environment, okay, where neither legs, neither wheel is the best choice, okay, these algorithms allow to find into quote optimal shapes, okay. And so when we think about, I don't know, deep ocean or space or other planet visit, it's kind of interesting set of approaches, okay? So the utilities has a pretty broad sense with shape generation here, okay? Just after something that I'm trying to do with a platform here we're developing in Tokyo, okay? is that so we're developing something that looks like a CI platform, continuous integration platform for robotics. Okay, and so it integrates a lot of simulation. But basically, people, they have their robots. Okay, let's say a robot arm. Okay, and they have a project, an application to develop. So the robot arm, for example, one of our project was a food. It was a food topping. Okay, we had to get food to put on top on something else. Okay, so to create the lunch boxes, very popular in Japan. Okay, and the thing is that the mission was, okay, you have a robot arm. Okay, and you have the end effector that was some kind of a fixed spoon. Okay, and so it's a fixed hardware. But what I introduced is so it's not generative AI, okay, because I'm using more parametric forms here. It's much easier and much better to control, okay. Where basically in simulation I generate a spoon, okay, that has some parameters, okay. So it may have a strange shape. Run a scenario in simulation to see whether we can get the food well and put it on top of something else, and score that. And depending on the score, what I was doing is actually writing a piece of software to plug to my 3D printer to print it, and after to send it to my team because my team lives somewhere else. Okay, and to cycle like that. Okay, and so the point here is that I'm not trying to minimize the amount of material I'm using, but I'm trying to find the optimal shape for a given task. So this is an example of matching the environment exactly. And it's pretty wild because, we had to get some kind of chicken nuggets, okay? So the spoon would work kind of work on this one, but we also had to put a salmon roe. A salmon roe is very popular in Japan, so it's something that it's a must-have, okay? But it's super sticky, okay? And so standard spoon, then it doesn't work at all, basically, okay? So this is where such kind of approach can be really interesting, and where, again, the utility is pretty broad topic. Okay?
So
I make a demo at some point.
I just want to comment. You see, there's a difference between using AI in order to build or design or set up the robot, the kinematics, the instructions, and using AI as a robot is working. In other words, having the AI as a safety feature, I won't go there because there's a cat, is on the robot itself, while doing, Eric, what you just said. Once we do it, you don't need much compute on the robot to use it.
Yes, for me here it was clearly about using AI techniques, okay, for design, okay, not directly on the robots. Okay, that's we are doing that as well, but not for this specific sub project, let's say. Okay. But you said to use AI for safety. I think most people don't use AI for safety. Huh?
That's why it's backwards. That's why I like it.
You are on mute, Venkat.
Oh.
Yeah. So these, if you search for Autodesk museum exhibits, you'll find a bunch of pictures. For some reason, their website is not loading properly. So this is just Google Images. This is the car I was thinking of. This whole thing has been shape optimized in AutoCAD using machine learning. So yeah, a parametric approach might lead to somewhat more conventional looking designs, and there's a bunch of others. If you search, you'll find, here's one. If you look at the third one on the top row, that's kind of a wheeled car kind of configuration. I didn't see this when I was there several years ago. And yeah, you get other things like random structures and shapes that end up very weird looking compared to how a human would do it. So this field was there like 25 years ago. It was called shape optimization. So this was pre-AI. But if you ran certain like shape optimization algorithms for, say, like, minimum weight strut that holds up a shelf, like a normal human would design a strut with like, a right angle and then maybe a diagonal bar. That's how you would like typically learn to do it in mechanical engineering. But if you throw this algorithm at it, it'll create like some sort of weird branching tree-like thing, and you'll be able to show that it actually is more efficient than whatever a human would come up with. So I think the shape optimization for minimum material is the best developed version of this. But yeah, you can do more kinds of structural optimization, and I think there's a continuum between that and learning behaviors, right? Like think about reconfigurable robotics. If you have like a robot that can have like 4 or 5 different configurations and you don't know which configuration to use for which application, learning that is kind of like exploring a restricted structural design space, right? Same thing with like, from traditional design, safety looks like a clearly distinct concern from navigation. But I think if you sort of like, I don't know, remove all top-down structure, that distinction might be one that emerges. Like, maybe there's not actually a clean distinction between keeping the robot safe versus getting from point A to point B. So I think this needs a whole fundamentally. That's why I was saying, like, what does AI first design look like? But also, I think in terms of connecting to the momentum from last year, I'm curious to see, like, if we were to do an AI first version of the forecaster control thing, what could that be? And I'm thinking of, I saw this approach. I don't know. Again, everything I know is like 20 years old, but there was this approach called co-evolutionary robotics, where the human in the loop would basically be the supervisory cost function. So the idea there is, if it's like a very messy application and you can't a priori say that I'm optimizing or solving for this, one way to do it is iteratively, right? You have like an evolutionary algorithm that's coming up with designs, and then a human looks at like basically A/B testing. It's like, all right, here are 2 options. So let's say we're talking about rovers. There's a Mars type environment, and this algorithm is throwing up options, and the human in the loop doesn't have a clear idea of what a good rover is, but has kind of like good taste in comparing to all alternatives. So if it shows us 2 alternatives, you might be able to say option A is a better rover, option B is a worse rover, and I don't know why.
No, wait,
And then you evolve.
RLHF.
Yeah.
I'm just
It's the
stopping you
RLHF.
a second.
Yeah.
So what you're saying is that we will do it in simulation, and the simulation will show us 2 options, and we'll choose one, and then the simulation optimization will continue from there, and again show us 2 options. We'll go on from there.
So that's the classic approach. The reason I thought of this particular approach is it lends itself well to what Anuraj did on Forecaster. So the frame could show, instead of like turn left, turn right, it could be that the tumbler robot has like weird architecture A versus weird architecture B for motion. And it's like, all right, which way of moving do you think is better? This straightforward and turn on reverse, or is it, do you want to control left and right? So I don't know. So it feels like there's something there. Like it's a way to like leverage the orchestra, and you can add money there, right? Like whoever pays more gets to train the robot more.
One way to go is like what Rhett was trying to do last year, I think. I think you had done something similar to, like, you had asked ChatGPT. You were trying to control it with ChatGPT, right?
Yeah. Which I haven't tried this yet, but apparently the new Gemini model is like just a rock star at being able to draw bounding boxes around things. And that would, like, GPT-4o is just kind of trash at locating things in images, but newer models are apparently much better. So I can imagine it working better now.
So I saw this demo. I think it came out last week in the end of around New Year's. So this guy is basically running Llama model locally and trying to control a robot.
Oh.
Llama running on what? Can you turn on the volume? Oh, I can't.
So the Llama runs on the robot, you mean?
Sorry?
Locally, you mean it runs on the robot?
No, I think there is I think he's running it on a Jetson Orin somewhere, or some NVIDIA
Okay.
GPU, and then trying. So this robot, I think, only has Arduino and some motor controls, and then uh, probably he's transmitting the data to the local model, and then controlling it. So I'm not like gone into the details, but let's see what this guy is doing.
These are speakers on top? I see.
Is that the internal? I can barely hear, but is that the internal monologue of the LLM?
Yes, it seems so.
Okay.
Yeah. He's not moving his lips.
That's very chipper.
What do you have to tell the LLM for to give you this type of internal monologue?
Yeah, that's an interesting question. I wonder if it's actually not the instruct or chat tuned, and it's like to have an inner monologue like that is
This is chain of thought, right?
unusual. It's yeah,
It
but
would
it's
be something like,
continuous.
find a interesting book to read and then think out loud while evaluating your options. It sounds like it's that kind of process.
Yeah, or I guess it's being delivered an image, so then it's responding to the image.
Could you share this link, Anuraj? I'll want to look at it later and hear the audio properly.
Yeah, so I think like this, what this guy is saying, that he transmits the data from his robot to the his GPU computer, and which has a GPU, and then it's processing it there and returning back. So basically, you could do this like directly connecting to ChatGPT or Gemini, and then getting the data via an API if the robot has internet. But I'll post this in the Discord channel. But this is something what Red was trying to do last year. So like, so we what we could do is like have the frame, and then people could talk into it, and then send the data or commands to the Gemini model or ChatGPT, and then interact with the robot.
How good are the AIs or these models at actually optimizing, making trade-offs between more than one thing? Like having more than one design goal, because I can certainly see the case where you could optimize for something like use the least amount of material, but then you might get a design that has other flaws, like it's hard to maintain, or it fails in some safety aspect. I think a lot of the challenge of actually designing anything that works in the real world is actually balancing several different design constraints and criteria. Um, so, and like one of you mentioned ocean exploration. I heard a really interesting interview with James Cameron about the vessel that he designed to go down into the depths of the ocean. And one of his key insights was to actually optimize his vessel for the trip down, so that like the drag or was less going down than it was when he was actually at the bottom moving around, because the most of the time spent in the trip was actually going up and down. So but that was definitely like a design choice and an insight that he had, that that was the most important thing to optimize in that particular context. But I could see like there are definitely times you might want to actually solve for more than one criteria. Like you might be able to get AI to give you, oh, this is what it is optimized for weight, or this is what it is optimized for drag, or this is what it is optimized for the amount of material, or volume, or whatever you decide. But then you can you might have to look at like 3 or 4 of those things that it's optimized for, and then make some compromises or combine the ideas from the different ones or something, because usually you don't want a robot that's purely optimized for one thing. It probably has to meet some other criteria too.
We optimize for producing paper clips.
Yeah, but instead, if we use this frame thing, the buttons can, instead of being moved forward, backwards, or choose design A, choose design B, we could offer the person the next 5 optimization cycles, should they be on size, weight, energy efficiency, coolness factor, and so on. So we could take what you said and plug it immediately into this frame mechanism we're talking about.
And in terms of what the AIs can do, they can basically do anything you're clever enough to prompt, but all the cleverness lies on the prompting side. So I've had success with asking chat GPT things like, what are the things I should consider in designing X, Y, and Z, and suggest a few possible alternatives considering different trade-off points. It understands that in high-level strategic intention very well, and it'll follow it. It'll say, all right, if you want to, I don't know, I'm making this up, 3 ways of cooking Thai curry that have different qualities, it'll actually understand the prompt and produce 3 options and so forth. But if you ask it a more, what I would say, an agentic question of what kind of robot do you want to design, and think through the process and come up with various considerations, it tends to flounder. So that's one piece of the answer. But the other piece is, I think you've got basically 2 toolkits to draw on. If you want to do extremely aggressive optimization for extreme environments like undersea, you would obviously use a lot of detailed mathematical modeling of whatever you're doing. And as far as I can see, the LLM or LMM based things don't seem to be very good at that. They can do small things that they can produce Python optimization scripts for and stuff, but they can't do very detailed complex modeling. The other toolkit is the more qualitative stuff. In very general qualitative terms, they can reason through a problem, but then translating it into a technical problem, that bridge, I think it's not state of the art. So the short answer to your question is, this is I would say most of the kind of thinking you're referring to still has to be done by either the human designer in the loop or the human teleoperator in the control loop, the high level sort of thinking.
I'm not sure that it was covered, but basically, Elena, on what you refer, yes, it's definitely a problem, okay? But in my experience, ultimately, it's an iterative process. And this is also where simulations, and so here we're talking about simulations because it's pretty cool, and because it's when it's visual with a solid physics engine, it can be meaningful. But in older practices, okay, we had simulations that were not visual. Okay, if I would still have them. Okay, I don't remember what I was using. There are things like MATLAB and all that are used. Okay. And so the thing that in all those activities, when we want to build a system, as you know very well, okay, well, it's iterative, and so we have an overall goal, okay, but we tackle systems one after the other and correct course step by step as we do smaller simulations, and after we plug the components together. And of course, after they are when we plug components together, it doesn't mean the thing as a whole will have the properties. And so we need more testing of the whole thing, integration testing, and finite element plugging, stuff like that. Okay. But the thing is that the way personally I practice it and I observed in different disciplines is really iterative, where we tackle the systems. The problems one after the other. So, for example, one of the cars that Venkat showed at the museum, okay, but maybe we want to minimize the materials, but we also want to be safe. Okay, so there will be such list of qualities we must have. Okay, and maybe prioritize them. Okay, and explore. Basically, it's a big state space to explore. And so this is where numerical approaches are very useful. And on top of numerical approaches, optimization approaches, and AI is one of them, at least here, can help a lot, okay? To speed it up, and maybe to also find solutions that a human would not find easily or ever, actually, by lack of time or by lack of imagination.
So what is your iterative process like? Like what maybe talk me through like what one cycle would be like.
So that links back to the example I gave earlier with I have a robot arm that has to pick food, okay? And so by working on it after some time, I realized that the end effector, okay, which I turned it into a spoon. It was not a spoon before, okay? So it's basically to narrow down where to optimize, okay? And so here it's a relatively simple case because I only have one thing to optimize, okay? So and so the kind of I have to identify some kind of function to optimize, so the utility function that Meyer was talking about. And so here, for example, for the salmon roe, is to count the number of salmon roe that end up at the target's position, basically, okay? But also the number of salmon roe that we can pick at once, okay? So it's a bit simple to see, but I remember doing an Autodesk tutorial, okay, where we had to design some kind of a shape, but I don't remember what the shape was for, okay. But there were what was very interesting. Maybe that's why that biased my memory, is that there were several factors we wanted the shape to be good at, okay. So one of them was actually to use as little material as possible because we wanted to 3D print it after, okay? But another factor was it must be something we can print, okay? And so then it's a more complex formula, but people very smart in 3D printing have figured it out apparently, okay? Because I don't know whether you're familiar in 3D printing, but when you have a CAD, okay, a 3D object to print, you can put that in a software for your printer, and at some point you have to prepare the shape for the printer. And this is basically slicing and such kind of things where basically it solves such kind of problems, okay? So sorry, there was another thing. Oh, yeah. And there was another factor to optimize against. So I will simplify that to 3 factors to optimize. So one is the amount of material. The second one is that can be printed. And the last one was it must be able to sustain some load, okay? 1 kilo or something like that. And so my way to do it was to optimize one after the other, but one on top of the other in this case. Perhaps because it was simple enough, because in more complex systems, it's not always possible to do that, okay? So then I have much less experience, and I fall back to my older knowledge, which is mainly about numerical computation and simulation.
Okay, so say your robot with your spoon, it picked up a certain amount of salmon roe, you measured how much it was, you changed its shape, and you 3D printed it, and then you tested it again, and you saw how much salmon roe it could pick up. You've optimized all of those things. How do you get it to the next iteration? Like how do you make it even better?
Okay.
How do you learn?
Mm-hmm. And so I used the word scoring earlier, okay? And so this is another function, okay, that uses the parameters we have identified. So in my salmon roe scenario, my 2 scores are based on the number of eggs I can pick with the spoon that has been generated, and the number of salmon roe that I can actually place. Because a robot arm can be a bit it can move. The word doesn't come to mind, but the movement can be a bit too rapid, and so some eggs can fall down. They are super sticky, but it does happen, okay? And so basically, it's to do that inside a simulation in my case, okay? So with MATLAB or the name doesn't come back. The tool I was using. It can be done as well that way, okay? But here it's doing it in simulation is pretty nice because we can see what happens. But basically, we choose a spoon design. Okay, we have scenario that is predefined. Okay, so the scenario is the robot doing manipulation, pre-computed movement to pick and to place. Okay, and go back to its original position. Okay, so we run this scenario, and in the end, it's in simulation. So we have 3D objects, so we can count them. Okay, we have an object idea for each of the salmon row. Okay, and so we just count. We have a simple scoring formula here. Okay, and based on that, I stopped. This is a project that I'm continuing, but I'm going to do some optimization using Bayesian optimization. Okay, but right now I haven't implemented that. Okay, so right now it's just a simple score where I'm trying to do something much more naive, which is a bit like a grid search, if it speaks to everyone. Okay, grid search is that you identify the number of values you have, okay, and you just explore them either at random or do a dichotomy or stuff like that. Okay, and so it's not super smart. Okay, but it allows to cover the space. Okay. And so what I've been doing so far is just to run it until completion. Okay, so we have a number of values to explore. It will do all of them. It's in simulation, so we just let it run. It's a waste of energy. Okay, but at the end we have a report that for these scenarios, what was the best configuration basically. Okay, so for that spoon, this is where we got the most salmon roe picked and placed.
Can we, since we just have a few minutes left, there's one that I think Rhett posted a couple of weeks back that I think is worth looking at. This Genesis thing, it seems pretty impressive. This is the first time I'm looking at it. Did you look more deeply, Rhett? What is this?
I've been, folks on Twitter have been talking about it a little bit. It's a little like hard to really understand what's happening because they have this amazing demo video of using generative language like you would with a chatbot and to generate 3D worlds, and they released everything but that piece. It's like, well, wait, okay, so what's the thing that's left? I'm starting to think now though that this is very much on par with what NVIDIA has released, in that it's a physics engine that's really optimized for building robotic simulations, just like theirs is. But I haven't dug super deep on it.
This looks worth looking at. They seem to have like a lot of models of like the unitary thing. This, by the way, Mayor, this is an example of what you were talking about. This physically is a hand robot, so it should do gripping type tasks, but in the simulation, it has to walk using the hand, right? So that's the kind of thing that I think is really worth exploring, where it can do, all sorts of weird things. But this seems very general, way beyond robotics. Oh, soft robots.
There is a blog post that has been published that reviews this. Okay, because for me, when I saw it, also it's super impressive, and also it's 100% Python. Okay, and so it's a bit mysterious how they can get performance with only Python. Okay, so of course it's because they are using libraries like NVIDIA optimized libraries and so on. But I don't remember there is a blog post. I will find the link and share it because it's a review from the University of San Diego, I think, the developer of a simulator called Sapien. Okay, and it's a simulator also used in robotics that is not super well known, but for a few years they've done a competition, and I even participated in 2021. Okay. And the thing is that he makes a really, really comprehensive review, okay, including reviewing the actual performance of Genesis, okay. And so he reports that in the page we are seeing now, it's basically they are overly confident on the scores they get, okay. So by his measurement, So the Sapien guy, by his measurement, there is definitely a performance boost on some activities, but it's not as far as what they claim to be in here. Okay. But for me, what my takeaway from my readings on this one, and I also looked a little bit at the code, okay, is that there are a lot of interesting ideas in it, okay. But it's, for example, in the cases I'm working on, we decided not to use it basically, okay.
So there's NVIDIA's thing, but in general, this seems like a big vector for the future. So complete world modeling, learning and simulation with like very sparse supervision and a lot of like generated training data. So feels like something we should.
Is this an open source version of? I think NVIDIA's thing is called Cosmo.
Well, NVIDIA is listed as a sponsor here, and this is like
yeah. What does that mean?
Well, maybe they just provided.
Or no, wait, it's a collaborate. One of the contributors.
They might have just provided, I don't know, subsidized GPUs or something. But this is a huge consortium, and all the names look Asian. So I have a suspicion this is like Asia centric. They do have 2 Chinese universities here. So, all right. But the last thing that was in our link hopper that I think is worth at least a minute before we sign off today is this ARPI AI hat. Anybody know anything more about it? It seems to do something. I don't know what this demo is, but
hardware that connects to your Pi and gives it access to a dedicated processor specialized in running AI and neural networks. This allows your Pi to run some pretty smooth computer vision for only a few extra watts of power. Now, you could run this computer vision without the hat, and we have guides on how to do so, but with the hat, you get around a 20 to 40 times boost in processing performance. And all of this might seem a little complicated, but it's actually fairly easy nowadays, and we have an entire step-by-step video guide where you learn how to use the AI hat with simple Python code. We also do all the cool things from the beginning of the video, so if you want to check that out, you'll find a link in bio, and just for you, we'll give it away for free on the house. It was free anyways. This Raspberry Pi is currently running YOLO.
Right. So I think that was, unless I missed any link, I think we took a look at all the major links that were posted in the last couple of weeks. But yeah, definitely AI. Oh, there were a couple of other ones that were not AI related. Like there's an interesting post I saw on Substack about a guy. This guy is really impressive. He's like gone from nothing to like VTOL drones in just a few weeks. So he's like on his second iteration already. And he had I posted this. He had a very interesting post on like how power to weight of motors is really increasing, and there's some more on batteries. So I think, but AI is like orders of magnitude, like a bigger trend than anything else here. Like Yasha, I think, so Yasha is another member of this group who joins occasionally. Yasha is a hardware guy, so he's like very bullish on like motors and magnetics and things like that. But honestly, I think AI is eating everything else. So one thing definitely I'd like to have, I don't know, see as experiment with somehow is AI, and the simplest thing seems to be the ARPI hat is one thing we can try playing with, and AI in simulation.
But you might need ARPI 5. I think that hat connects via PCI, and only the ARPI 5 has.
It's still very affordable, right? Like $100 for the ARPI 5. I don't know. This hat must be another $100. Yeah.
Yeah.
All
I
right,
think
so
we have 5 minutes past the hour.
Yeah, we ended up spending the whole hour on like just reviewing developments, but I think maybe we need another session on, all right, can we go back to things we're already doing like Yakasar and the Farcaster experiment and find a way to like inject this stuff into that somehow.
Yeah.
Cool. Catch y'all later.
Hey, see you guys next week.
Good night.